Let's take a look at the sum and difference rules. Let f of x and g of x be differentiable functions of x. Then, the derivative of f of x plus g of x is equal to the derivative of f of x plus the derivative of g of x. Also, the derivative of f of x minus g of x is equal to the derivative of f of x minus the derivative of g of x. So let's go ahead and look at a couple of examples of how these rules can be applied. In our first example, we have the derivative of negative 3 over x squared minus 4 times the cube root of x squared plus 5. So let's go ahead and start by applying the sum and the difference rules. So we will end up with the derivative with respect to x of negative 3 over x squared minus the derivative with respect to x of 4 times the cube root of x squared plus the derivative with respect to x of 5. Now, let's go ahead and apply the constant multiple rule. We can apply that to these first two terms with the negative 3 and in the numerator and this 4 coefficient as well. So this would look like negative 3 times the derivative of 1 over x squared minus 4 times the derivative of the cube root of x squared plus the derivative of 5. Now, we want to be able to apply the power rule for the 1 over x squared function and the cube root of x squared function. So we will rewrite both of those in a form that allows us to do that. So using our knowledge of both negative exponents for the 1 over x squared and rational exponents and radicals to rewrite the cube root of x squared. So this would look like negative 3 times the derivative of x to the negative 2 power minus 4 times the derivative of x to the 2/3 power plus the derivative of 5. At this point, for the first two terms, this derivative of x to the negative 2 power, we can use the power rule. And for the derivative of x to the 2/3 power, we can also use the power rule. And then for the very last term, the derivative of 5, we can use the constant rule. So we're going to end up with negative 3 times negative 2 times x to the negative 2 minus 1 power. That's using the power rule on x to the negative 2 power. Minus 4 times 2/3 x to the 2/3 minus 1 power plus the derivative of 5 is 0. Now, cleaning this up, negative 3 times negative 2 will give us a positive 6. My exponent for x is negative 3. And if I have an x to the negative 3 power, I can rewrite that as 1 over x cubed. So this is really 6 over x cubed. Minus, and now we have 4 times 2/3. 4 times 2/3 is 8/3. So we have minus 8/3. And here we have x to the 2/3 power minus 1. 2/3 minus 1 is negative 1/3. So we have an x to the negative 1/3 power there. And so I can rewrite that as x to the 1/3 in the denominator, and then plus 0. So we have 6 over x cubed minus 8 over 3x to the 1/3 power as our derivative. Let's take a look at our second example here. Again, we'll begin by applying the sum and difference rule first. So we're going to end up with the derivative of 2x to the 7th plus the derivative of 5 over the square root of x minus the derivative of 8. So we use the sum and difference rule there. Next, we will apply the constant multiple rule for the 2x to the 7th derivative and the 5 over x squared derivative. So, applying the constant multiple rule, we get 2 over the derivative of x to the 7th power plus 5 times the derivative of 1 over square root of x minus the derivative of 8. Now, I can use the constant rule on 8. I can use the power rule on this x to the 7th, but I need to rewrite this 1 over the square root of x so that I can apply the power rule. So we end up with 2 times the derivative with respect to x of x to the 7th power plus 5 times the derivative with respect to x of x to the negative 1/2 power minus the derivative with respect to x of 8. Now at this point, we're ready to apply the various power rule for the first 2 terms and the constant rule for the last term. So we end up with, taking our derivatives now, 2 times the derivative of x to the 7th using the power rule is 7 times x to the 6 minus 1 power plus, and now the power rule for our next term, so we'll have 5 times negative 1/2 x to the negative 1/2 minus 1 power minus, and then our derivative of 8 is 0. So, x to the 6 minus 1 power is going to be x to the 5th. And 2 times 7 is 14, so we're going to have 14 times x to the 5th power, plus, then we have 5 times negative 1/2, so that's negative 5/2, x to the, and now x to the negative 1/2 minus 1 is x to the negative 3/2. So we have x to the negative 3/2 power here, and then minus 0, so we don't need to write that. So finishing this out, we have 14x to the 5th minus 5 over 2 times x to the 3/2 power as our derivative. I hope this helps.